This is a recap of the reading. So after you have read pages 8 through 11 and then pages 17 through 19 in your book here, it's in the keynote. Then you'll come through and have this recap of information from me, and you can fill out your learning journal. The book starts with the ability to do work or cause a change in matter. That's a vocab word for us. That is energy. Energy is the ability to do work, and we are focusing specifically on one type of energy, light energy. And light energy comes as a main source from what? Of course, it means the sun. That is our main source of natural energy that we get on Earth. We also have some artificial light sources too, right? We have light bulbs and we have things that create light that we make. So therefore it is artificial, where the sun is natural. Can you think of some other artificial sources of light? Think if you had a dark room, what would be giving light? Your iPads, clock screens, right? Digital things. Those are all artificial sources of light. Light is a form of energy and it travels in waves. That's a key factor. And we also know that it travels in a straight line. So imagining the sun here. And it's traveling in a wave from the sun, but it's traveling in a straight line. Okay? The waves are curvy, but the path that light travels is straight. And that's a key. We also sometimes call these little parts of light rays. So you may hear a light ray or a light wave. It's kind of the same thing. When a light ray strikes a surface, there's 3 things that it can do. If you think about it, I bet you can guess them. And the pictures are a big hint. The very first thing light can do when it strikes a surface is we say it reflects or it bounces. Right? What kind of surfaces does light bounce off of? Shiny surfaces, mirrors, etc. Something that's going to give you a glare of light back at you. The next thing light can do is it can absorb, and it can soak in and just stay on the object. When light stays on the object and it soaks in, it often transforms into heat. So think about it. If something is outside in the sun and the sun's just sitting on it, that object gets hot, right? If you ever sat on a hot car seat or something outside, it feels warmer because light has been shining on it. So reflecting and absorbing are 2 familiar words. The third thing light can do as it strikes a surface is called refract. And that just means to bend, or we say it transmits. It passes through something. So when light passes through something, it can bend, something like a window or glass or a lens. All right, well, let's move on. This word is a vocab word from the reading, and it's called electromagnetic radiation. Sounds really, really fancy for a way to say it's just the energy from the sun. And the energy from the sun comes in all different forms. If the sun was shining here and giving off these rays here, notice the straight line of the waves moving off of the sun. Well, some of it is seen and some of it is unseen. We don't see all the things on there, but the part we do see is called visible light. Kind of creative, right? So there's other forms of light that we don't see, and you know that because if you go out in the sun, you put on sunscreen, and that's probably because of this ultraviolet light. Microwaves send signals, and radios send signals. Those waves exist, but we don't see them with our eyes. We do see this part of visible light, and we call this sometimes the color spectrum. And if you look at the color spectrum, you see red, orange, yellow, green, blue, indigo, and violet. And sometimes we call that Roy G. Biv, and that just helps you remember the order of the color spectrum, right? The rainbow. But the real science term for that is a spectrum. Okay. So some fast facts about light that you should have read about, and we just recap this one. Light travels in a straight path, but it does travel in the form of a wave. Light can travel through a vacuum, and what that means is it's not what you sweep your floor with. Light travels through a region that has no matter in it. Light does not need matter to travel. So something like space, where there's no matter in space. Well, there's matter, but it's so far apart we consider it a vacuum, right? The light does not need matter in order to move and get to Earth. And finally, we know that light is fast. It travels faster than sound. It travels at this speed of 186,000 miles per second. Just kind of a random fact there. And if you think about it, if you've ever in a rainstorm, you see the lightning before you hear the thunder, right? You see the lightning before you hear the thunder. They happen at the same time, but light just travels faster. Lastly, there's 3 ways we measure light, 3 kind of properties of light that we refer to. One of them is when I take my light wave, I can take a measure here from the very top of a wave called the crest, from the top of one wave to the top of the very next wave. That's called crest to crest. We call that wavelength. It's a distance, so the word length in there makes complete sense. Wavelength is the difference between the waves, and it could be measured from the top, the crest of one wave, to the crest of the next. It could also be measured from the trough of one wave to the trough of the next wave, the bottom to the bottom. It doesn't matter. Light also has amplitude. Amplitude is the amount of energy, is really. So if you look at my light wave here, the sample light wave, and it's about the energy, this line would be resting point when there is no light. This wave that moves up and down, how high it goes from resting point, the height of it, refers to how much energy it has, and that's called amplitude. And finally, the last word for a way we can identify the differences of waves is called frequency. Well, the word frequent maybe is a familiar word to you. Frequent is how often you do something. And in a light wave, frequency is how often a wave will crest in a given time. So say this is a 10-second time frame. This first wave has a low frequency. It's only crested once and twice. This second wave of a medium frequency crests once, twice, 3 times. So it's a little higher frequency more often. And in this last wave with the high frequency, look at 1, 2, 3, 4, 5, 6. If it crests many more times, so we say it is a high frequency wave. I want you just to be familiar with those terms. You don't have to use them or do a lot with them, but they come into play in this unit and again when we talk about sound. And lastly, the play on words here, but how could we resist? Your future is so bright, like a bright ray of sunshine.